Welcome to Fun with Science, Engineering, and Technology. My name is Mr. Ross, and today we're going to investigate one of the simple machines, pulleys. A very fascinating subject, and they're used all over our everyday life, so it should be very interesting. My assistants this morning are
Waldemar, Pulleys,
and Ronnie.
All right, so what we're going to do is, just like I said, just a few experiments with some pulleys. Ronnie, what do we have over here anyway? We got a whole bunch of stuff. You know what it is? Sort of hold it up. And
This is a spring scale.
we have how many of those? We have
2 spring scales. We have
a meter stick.
meter stick.
Yeah, well, on one side it's like a yardstick. It has inches, and on this side it has centimeters. All right, we have 2 of those, and we have what is that? It's a pulley, right?
Yeah, this is a sort of a pulley.
Yeah. So we have 2 of those.
We have 2 pulleys.
What else we got?
A string.
Some string. Some paper clips. Everybody has to have paper clips, right?
This is Play-Doh.
clay.
Clay, right? Yeah, what else? Were you missing something? How about these black things here?
And these are,
Mass weights, right? They're
yeah, we
little
weight
weights,
them
right?
on
Those,
Right.
this
those
thing.
And that thing there is a what?
the weight.
That's it. This is a digital scale. Actually, it's a very accurate digital scale. All right. So we have 2 kinds of scales. We have the spring scale and we have this digital scale. Now this spring scale, right? It has 2 sides to it. One over here says grams, right? Where it goes from 0 up to 1,000 grams, and then this other side is what's that?
Newtons.
Newtons, right? And it goes from 0 to 10. All right, and sometimes when we want to measure force, we need, and use some of the formulas, we need to measure it in newtons, or we can measure force either in newtons or grams. For some of the experiments, we do it in newtons. All right, and if you look at the scale, all right, 100 grams is how many newtons?
1.
1 newton. 200 grams would be?
2.
2. All right, so what we're going to do is over there we have an apparatus stand, and I have it rigged up with some paper clips on it. And what I want you to do, Ronnie, is take one of the pulleys, right? And why don't you take the one with the string? It'll probably be a little bit easier.
This one.
And why don't you help him a little bit? Ronnie and Waldemar, what I want you to do is I want you to take that stand and one of the pulleys and set up this arrangement here, like this.
Okay.
All right. So what's happening?
Well,
Nothing, right? Right. That believe it or not, that machine has a name. It's called an Atwood machine, right? And it's named after Sir George Atwood, who back in 1787 used that machine, right, to check on acceleration, how fast things would start moving and how fast they were accelerated by gravity. All right, we're going to use it for a little different purpose today. And if you look at it, Ronnie, is it other than things just swinging back and forth because we're bouncing the floor a little bit? Is it doing anything?
No.
Just nothing's going up and down or whatever. All right, what I want you to do, and why is that?
Because they both weigh the same.
They both weigh the same. Both of those weights are the same, so we got the same force pulling down on each side, and it balances up. All right, so what I want you to do is I want you to take a little piece of clay and put it on one of them. All right, let's see if it starts to move.
Stick it on the
Stick it on there, yeah. Did it move?
Yeah, that one went up.
Well, yeah, but it's because you pushed it up. But I mean, is it moving now?
No.
No.
No. All right, but that one with the clay on it was going to weigh a little bit more than the one without the clay, right? So there should be more force pulling down on that string than there is on the other one, right? But it's not moving yet. Here, put some more on it. Still not going down. Wonder why that is. You have any idea why that might be?
Because I think the clay is too light.
You think the clay is too light, but if there's a little bit more force on this one than there is over here, it should be going down, and we got some more force on it. And why isn't it going down? Here, let's try some more. leave that one alone. Right. You're not having much success, Ronnie.
Oh.
Still not going down?
Maybe it's because I'm putting it all in one spot.
That's okay. It's all right. You can't drop all the science experiments on the floor. Right. A little bit more. No, it's still not enough?
It moved a little.
It moved a little?
Let's see.
Let's try some more.
Oh, it's moving.
There it's going, right? Okay. So finally, after we got enough clay on there, right, added enough extra weight on that one side, it started moving. Give me the clay a minute. Let's take and move
All of
it.
it?
Yeah, all of it. Right. So let's see how much clay we had to add. All right, I have this digital scale, and it's set up to measure grams. So what do we have to add?
21 grams.
We had to add 21 grams. In other words, we had to put 21 grams more weight on that one side to make it move. If we take this 21 grams and we put it over here, right now they're standing still, right? We take it and put it over here, what's going to happen?
That's how it can go down. That's how it can go up.
It's going to go the other way, right? Okay, why does this just stand still when the two weights are exactly the same?
Cause what does it stay still?
Why does it stay still? Yeah, when the two weights is exactly the same. Why when I just put just a little bit on there, it doesn't move?
Probably
They
cause
still, this side weighs a little bit more than that side. Why doesn't it move it? You got more gravity force pulling down on this side.
But I think that
Because
I think that this still weighs the same as this, either with the clay.
You think so?
No.
You think that they
I
both
think-
weigh? Even if I put this on it, it weighs the same? Right, it weighed 240. Now it weighs 243, right?
Or just gain 3 grams.
I think it's because the clay doesn't have no effect on it. It doesn't have no effect on it.
Only has
No,
effect when
wait.
there's a
It
lot.
doesn't have any effect. Well, look. What's it weigh?
240,
240. I put the clay on it.
243.
243. So, if I were to hang this up here right now, both of these things weigh the same. That weighs 240.
Oh,
All right.
the-
This one now weighs 243. Why isn't it going down?
I think it moves like 3 more grams. It goes down like a little bit more. It went down a little. So they gained 3 more grams.
I want to add some more.
It goes down more than before.
It's not moving.
No, it's not going down.
No.
Yeah, it is.
Yeah.
The reason it's not moving is because of something very, very important.
Gravity?
Well, gravity is pulling down on both sides, all right? And it's pulling down on this one a little more than this, all right? There's a little more gravitational force, or not more gravitational force, but this weighs more than that. So this string is being pulled a little bit more than that string. But what the thing is this, it's not moving, right? And the reason it's not moving is because this pulley is not very good, right? If we take one of these pulleys and go like this, what happens to it? If I spin it, what happens?
Like slows down.
It slows down and stops. Why? When you did the go-karts, right, and they slow down and stop, why did they slow down and stop?
Cause we had to rewind it again.
Yeah, but why did it stop? Why didn't it just keep going?
Why it
Because
stopped?
the wheels.
No, it stopped because the rubber band just like wasted.
Okay, they waste, yeah, the rubber band, but you had it going pretty good with the rubber bands, all right? Why didn't it just keep on going? Why doesn't it? Why when I take this and I go like that, why doesn't that keep on going? Very important thing. It's the reason you were able to get to school this morning. And it was the reason that when you
They
got
don't
to
have
school, you could
force?
stop and stay here.
I think because they don't have force.
No.
Because you can't go on forever.
Take your hands and go like this. What happens? What happens? What happened to your hand? What happened?
I get hot.
It gets hot. Why? Because of the friction.
Friction.
Right? Friction, right? When there's these two things rubbing, your hands rubbing together, right? It's friction, right? And friction, you take your car, and you get your car going, and you, big car, right? And you push it, and it gets going. And the reason it slows down and stops, it'll eventually slow down and stop unless it's going downhill, right? It's because
The friction stops
friction stops it, right?
The heat.
When you're driving along, you want to stop the car, and you hit the brakes. What stops it?
The
friction.
The
The
friction.
friction, right? If it's on ice, what happens to the friction if we're on the ice?
It keeps on going.
If there's not much friction on when we're driving on the ice, so if you try to stop, it keeps right on going. Right? Why does it get moving to begin with? Why can I walk across the floor like this?
Because you
If
got
this floor was all icy and I tried to walk, what would happen?
you stay the same. You
My feet would slip, right?
Mhm.
Right? So now then, because there's friction between the floor and my shoes and my feet and all that sort of thing, I can go across. I can be walking along like this, and when I get to where I want to go and I want to stop, I can stop, all because of friction. Now, in our little machine that we have over there, right, there's friction in this pulley, and the reason it slows down and stops when I spin it is because of the friction, right? So now then, the reason, even though this weighs more than that one, right, and there's more force pulling down on this side than there is over here, the reason it's not moving is because of
the friction.
the friction, right? So now then, if I add enough weight here to overcome the force of the friction, what's going to happen?
It goes down, the other side
It's
goes
going to
up.
go down. And how much weight was that?
This is 20.
21 grams, right?
Yeah, 21.
If that were a real good pulley, right, and it had ball bearings in here and it was all lubricated real good, right, and we reduced the friction, then it wouldn't take 21 grams. It may only take 4 or 5 grams to make it move, right? But, so our pulleys, right, these are not really real good pulleys. They're all right for our purposes, right? But they have some friction in them. Okay, so that's called an Atwood machine, and it's not moving because why?
Because it don't have any weight.
Because the
weight,
two weights are equal, right?
And the friction.
And if I can add weight to one side, I have to add enough to overcome the friction before it starts moving. All right, so what we want to do now is we want to change our arrangement a little bit, and we want to hook up one of these. You didn't know you were going to have to work so hard, did you? Huh? All right. Hang the weight down there like that. Now, so we have one pulley, we have a couple spring scales here, and we have the weight down on the bottom. Now, what is the weight on this?
240.
240? Or about 250. All right, this scale is much more accurate than those spring scales, right? But 240. All right, so now if you try to pick me up, all right, I weigh 220 pounds, okay, and you're gonna try to lift me. What are you gonna have to do? You're gonna have to lift 220 pounds, right?
I'm gonna put all my strength.
Yeah, no, but both of you try to pick me up, all right? And if you both work the same amount, right, you're gonna lift how much? You're gonna take 220 and
Yeah.
you're gonna lift half of it, right? Which would be 110, and you're gonna lift 110, right? So if the two of you grab a hold of me, and each of you are gonna lift half of it, right? Those two scales over there, this weighs, what? We say this was 240?
240.
240 grams? How many grams are reading on that scale on the left?
125.
About 120? 125?
150.
125, all right. What's this one read over here?
125. About 120, I think. 25.
150.
About 150, all right. the scales, those are not real accurate scales, all right, because well, there's been a lot of students playing with them, right? But they both weigh about 120, right? The scale reads 120, this one reads 120. And that's what we say that down there? 240, right? We know that the weight is 240. So each one of these strings then is supporting half the weight. All right? So now then, let's do a thing. Let's take out one of the scales. Let's take this one out. Right? Because we. All right. Now then, took the spring scale out. What's that one weigh? Measure.
The same.
The same. Where'd the other 120 go? That one weighs 100. It's measuring 120. Where's the other 120?
On this side.
On that side, right? We just don't happen to have a scale in there to measure it. So, but there's 120 grams of force on here. There's 120 grams of force there. Okay. So now then, if you were going to use that pulley system to lift something up, right? How much force would you have to lift to use to pull something up? Let's say for a moment this was 100 pounds, right?
Yeah.
How much force would you have to put over here to pick it up?
To make that up?
Yeah, if it were 100 pounds. Okay. All right, so now then, Ronnie, you said what did that weigh? What did it measure?
I know what
About
it is.
120. All right, and this is 240 grams. All right, that reads 120. So the force required to hold that up is half of
Half.
the load, right? So now then, let's say if this were 100 pounds, right, how much force would you take to hold it up?
Half.
Half, which would be
50 pounds.
50 pounds, right. Okay, so now, that gets us to something called mechanical advantage, right? It's an advantage some of these machines have, right, which says what mechanical advantage we have right now is 2. And what that says is it takes half of the load to raise it, to hold it up, right? If the mechanical advantage were 4, it would take 1/4 of the load to hold it up. Right? So now an easy way to figure out what the mechanical advantage is, rather than measure it and so forth, is to look at how many strings or how many ropes or whatever we're using to hold on the pulley, right? That holds the load down here. How many strings do we have holding the load?
2.
2. So the mechanical advantage is 2.
Yes.
Right? If we had 3 strings holding the load up, mechanical advantage would be
3.
3. Right, very good. All right, so let's change this now and do a little different arrangement. Take this off of here. I'm gonna let you do it. I've destroyed it. We're gonna take 2 pulleys. Okay? And hook that up, that arrangement.
Yes, right there.
One there. You guys are getting good at this. We're going to get you a job as a rigger. You know what a rigger is?
No.
He's the guy that uses all these pulleys and simple machines to pick things up. And you may want to need a little longer string. That's why we have several pieces of string here. You know? All right, now, Ronnie, what is this spring scale read now? How much force does it take to hold up the load?
100.
100? All right, well, the scale is probably off a little bit. It's about 120, right? Which is half the weight of the load. Right. So what's our mechanical advantage?
Mechanical advantage. Right?
Yeah, mechanical advantage, right?
It's 3.
If it's 2, it's half the load, right? So right now our mechanical advantage is 2. We went from that real simple thing, which had a mechanical advantage of 2, to this very complex arrangement with a mechanical advantage of
3.
Is it 3?
Right. Yeah.
1, no 2 ones.
All right. How many strings are holding up the load?
3.
3?
1, 2, 3.
You sure?
Oh, no.
Yeah, okay, yeah, you do. You have 3, right, I'm sorry. All right, so you have 3, right? So it's about one third of the force required to hold it up, so it's about 100, a little less than 100. So we have 3. What if we were to take and let me take this arrangement we have here very quickly. I'm gonna change it for you. Where are we? You ready to go?
Now we used to say like now
Now
we
then.
switch it around.
Well, we just switched it around, all right? So that now then, still have 2 pulleys, right? I still have my string scale down here. I still have my load here. But now then, how many strings are holding up the load?
3.
How many?
2.
2. So what's the mechanical advantage?
2.
2. Well, before we had 3, right? We turn it over like this, okay? And what we're doing is we decreased the mechanical advantage, and what we did is basically we changed the direction which our force is being applied to input in the machine. Right? Before it was up, and all 3 strings were holding the load. Right, so depending on how we configure our pulley system, we can get all kinds of mechanical advantages. I have another one over here. I have some pulleys. Actually, I got 1, 2, 3. I have actually, I have 7 pulleys, right? Now, if I were to take this and put my load down here like this, right, on it, what's my mechanical advantage?
7.
7? I got 1, 2, 3, 4, 5, 6,
Yes.
7. 7, right? That'd be my mechanical advantage. Right, so if this weighs 700, I've had a load down here with 700 pounds. How many pounds do I have to pull to hold it up?
Half.
Well, 7, mechanical advantage is 7. 7 into 700 is what? 7 into 7 is what? 1. So it would be, I'd have to have 100 pounds pulling down on it. Now then, if I take and turn it over, right, and I put the load down here, now then, how many strings are holding it up?
6. Yes. No, it's still 7.
Still 7? Those 7 there, plus what's this one doing over here?
8.
It'd be 8, so my mechanical advantage is now 8. All right, so we can, what we've just shown is we can take and we can use pulleys to lift big heavy loads, depending upon and how much force we have to put in to lift a heavy load is depending upon the mechanical advantage that we have. Right? And what's the one thing that's going to add a little bit to the effort we have to put in? When we first started out, what did we do?
First we.
This pulley has what? Okay, let me get one that doesn't have a string on it. Right? What's this pulley got in it? What's the word? What's the word?
Heat. Has heat.
Well, they're generating heat, but what's the word?
Deluxe.
Friction. Friction, right? It's the thing that's going to cause it to slow down, right? Because of the friction in there on the little bearing in the pulley. And this not being a very good pulley, it's going to slow down pretty quick, right? Friction is the thing that allows you to get to school in the morning, because if you didn't have friction, you wouldn't be able to walk, right? And if you did get going, right, without friction, when you got here, you wouldn't be able to stop. And you'd be all sad and disappointed, right? Wouldn't you? If you couldn't get to school in the morning and you couldn't stop when you did get here, you'd really be disappointed. I know, I can tell. You're laughing at me, right? So, all of the simple machines have some friction in them, including these pulleys, and they're very useful. Almost everything we work with has some sort of pulley in it, like your automobile, right? Has a couple pulleys in the engine, right, to make the fan turn and the water pump go and run the water through the engine to cool it, right? Elevators have pulleys that raise the cage in the elevator up and down, right? So they're very useful, simple machine. All right, that's it for today. You can go home, and if you don't have to have a pulley that really turns like this, right, you could use a round stick or something, piece of metal, whatever, anything that you could put a rope around or a piece of string around and fasten down some way so you can pull on it and lift loads. All right, that's it for today. I hope you enjoyed the show, and we'll see you next week. So.